Hi, this is Mrs. Sigala, and this is your homework. Now I'm going to split up homework 7.5 into at least two different sections. The first section will cover specifically covalent Lewis dot structures, and so that way this video won't be too long. Alright, so we're going to start with the first portion. Make sure you have your periodic table of elements, and what I went ahead and did is I went ahead and labeled the number of valence electrons for each group. Okay, so we know valence electrons for the representative elements, which are groups 1, 2, and then 13 through 18. Alright, so the first one's asking how many total electrons do two atoms in a double bond share. A double bond is represented by two dashes. Each dash contains two electrons. So in this case, it would be 4 electrons. What about in a triple bond? A triple bond has 3 dashes. Each dash represents 2 electrons, so it will be a total of 6 electrons. All right, number 3 says, underline the central atom in the following covalent compounds. So quickly, I'm going to write down the rule for this. The central atom will always be found in least amounts. You can also identify a central atom because it usually is the first atom listed. However, it will never be hydrogen or fluorine. Okay, so if you have hydrogen or fluorine listed first, skip it and go on to the next one, and that can be your central atom. So A, it says underline it, the central atom. So A, the one found in the least amount would be phosphorus. There's my central atom. H2O, oxygen. There's only one oxygen and 2 hydrogens. C, carbon is my central atom. D, well, in this case, it can never be hydrogen, so we can skip hydrogen. And then it'll be the first one listed. Okay, I know that there's 3 atoms total, one of each. NH3, in this case, the least rule applies. CO2, least. B, Br3, and SiCl4. Okay, Si would be your central atom. Okay. All right, so let's look at some Lewis dot structures. Okay, so it says draw the Lewis dot structure for each of the following molecules. In this case, first, let's identify the rules that we follow. Okay, so I'm going to write them down here on the bottom left. The very first thing that you want to do is write down the number of valence electrons. Okay, for a molecule. Second step is choose your central atom, if there's one. Third step is bond other atoms to central atom using single bonds. Okay. Fourth step, I will fulfill the octet rule for the outer atoms first. First, a single bond is represented by a dash before I move on to the next step. Fourth step, okay, fulfill octet rule for outer atoms. Last, fulfill the octet rule for central atom. Okay, and this part, the last step, can also include like maybe in this case, this is where you would have to share additional bonds. So maybe you could potentially have multiple bonds, meaning double or triple bonds, in order to make sure everybody fulfills that octet rule. All right, so I'm going to reference these steps as we go through these problems. So the first one is F2. So first, I want to find out how many valence electrons there are for F2. So fluorine's in group 17. So by looking at it, I know that each fluorine contains 7 valence electrons. Oops. Which it says here. So I have 2 fluorines. So I'm going to have a total of 14 valence electrons. My next step is choose my central atom. Well, in this case, we don't have a central atom because we only have 2 fluorines. We don't have more than 2 atoms. So I'm going to go ahead and go on to step 3, which is bond atoms using a single bond. So I'm going to write down the fluorines, and I'm going to bond them using a single bond. So in this case, I've used up 2 valence electrons. So what I like to do on the side, here's what I'm starting with. I just used up 2 because this bond right here equals 2 electrons. Okay, so I have 12. My next step is to fulfill the octet rule for outer atoms. So in this case, I have 12 electrons left over. I need to split them between these 2 fluorines, so each one gets 6 electrons. So here's 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. I've used up all 12. Now I need to check if each one of them fulfills the octet rule or not. So here's 2, 4, 6, 8. This fluorine is happy. 2, 4, 6, 8. This fluorine is happy as well. Okay, so another way of checking is by looking at all of the electrons around your molecule. And I'm only going to write on this one, not on the rest, so that way you can identify what I'm adding. So I want to make sure that my total atoms used equal my valence electrons. So now I'm going to add them all up. Here's 2, 4, 6, 8, 10, 12, and 14. Do they equal? Yes. Okay, so if the electrons that you've used so far do not equal the total number of valence electrons for that molecule, something's wrong. Okay, all right, so I'm going to move on to hydrochloric acid. Again, I don't have a central atom because I only have 2 atoms in this case. Hydrogen has 1 valence electron. Chlorine has 7, so I have a total of 8 valence electrons. That's my first step. My next step is to add a bond between these. Hydrogen only has 1 energy level, so hydrogen is happy with 2 valence electrons, so hydrogen is fulfilled. So now I have to make sure I've used up 2 electrons, so 8 minus 2, I have 6 left. So chlorine will take on these 6. 3, 4, 5, 6. Alright, so now what do I look? Is hydrogen happy with 2? Yes. Is chlorine? We have 2, 4, 6, and 8, so chlorine's happy too. Next, I have nitrogen triiodide, and again, this is going back to nomenclature. Nitrogen, and if it's tri, I'm going to have 3 iodines. Alright, so first I'm going to identify the number of valence electrons. I know nitrogen has 5. Each iodine has 7. But I have 3 iodines, so I actually have 21 plus 5 is 26 valence electrons. My next step is choose my central atom, or identify it. In this case, it'd be nitrogen. Here's nitrogen. I'm going to bond all other atoms to the central atom using single bonds. Here's 1, 2, and 3. Okay. Then I'm going to fulfill the octet rule for the outer atoms first. But first, let's do the math here. I have 3 bonds, so I've used up 6 electrons. So I'm going to subtract 6. I have 20. In this case, since each dash represents 2 electrons, each iodine has already used up 2 electrons. But now I'm going to fulfill the octet rule. So each iodine requires 6 valence electrons. Here's 2, 4, 6, and then this bond is 2. So there's 8. 2, 4, 6, and then there's 8. So there I used up 18. So I have 2 valence electrons left. So now I'm going to fulfill the octet rule for my central atom. So far, nitrogen only has 6 valence electrons, so the remaining 2 will go with nitrogen. Again, I can check, and if I add all of my electrons, including those found within the bonds, I'm going to end up with 26. All right, next I have water. We all know that formula, H2O. Hydrogen has 1 valence electron. I have 2 hydrogens, so I have 2 so far. Each oxygen has 6, so I have 8 valence electrons. Okay, now again I'm going to choose my central atom. In this case it's oxygen. Next step, I'm going to use a single bond to bond each hydrogen. Alright, so far I've used 4 electrons. I'm going to subtract 4 from 8. So I have 4 left to use. I look at hydrogen. Hydrogen's already fulfilled its octet rule. It doesn't need 8 valence electrons to have a full energy level. Hydrogen and helium are those exceptions where they only need 2. So now I'm going to skip step 4, and I'm going to go to step 5. I'm going to fulfill the octet rule for central atom. Because right now oxygen only has 4 electrons, we have 4 left, so I'm going to add 2 and 4. There we go. And everybody's happy. Alright, here we have some more. We have HCN. Let's look at valence electrons. Hydrogen has 1, carbon has 4, so there's 5. Nitrogen has 5, so there's a total of 10 valence electrons. Next, I'm going to choose my central atom. We know that typically, in this case, there's only 1 of each element, so that rule doesn't apply. In this case, we look at the central atom. So it cannot be hydrogen, so in this case, it would have to be carbon. Okay, so we have carbon. We're going to connect them all. Here we go. By connecting these, I've used up 4 valence electrons. So I have 10 minus 4 equals 6. Alright, so in this case, hydrogen's happy. It already has 2 valence electrons. We have 6 electrons. So I'm going to distribute these to nitrogen because that's my next step. Fulfill the octet rule for outer atoms. Alright, so I've used up these 6 valence electrons. So nitrogen is happy because it has 2, 4, 6, 8 valence electrons, but carbon's not happy at all because carbon only has 4. So these need to go down here. Okay, once they do that, they disappear from over here. So carbon still has 6, carbon's still not happy, nitrogen still has 8, so it's not missing out. So then now these bottom ones need to go over here as well. So nitrogen has to share some more. Okay, so now we do the math. 2, 4, 6, 8 for nitrogen, 2, 4, 6, 8 for carbon, and everybody's happy. All right, let's look at our next one. We have CH3I. Okay, in this case, we have a tie between which one's bound in the least amount. So you have carbon and iodine. And hydrogen is not our first one, so again, it doesn't apply to hydrogen. So in this case, we have to go with our first one. Our central atom would be carbon. Before we do that, though, we have to identify the number of valence electrons. We know carbon has 4. Each hydrogen has 1, but we have 3 hydrogens. So there's 3. And each iodine has 7. So 7 plus 3 plus 4, we have 14 valence electrons. All right, so carbon's my central atom. Here's hydrogen, 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 and here's iodine. Let me erase this dot so I won't be confused. put this hydrogen back on top because it needs to be on top. Here we go. And let me see. Here we go. Alright, so by bonding all these, I've used up 8 electrons. So 14 minus 8 is 6. Alright, so all the hydrogens are happy. Okay, and now these 6 are going to be used for iodine because that's the outermost atom. 2, 4, 6. So I use them all, I cross out my 6. So iodine's happy with 8, and it just so happens that carbon is also happy with 8. I have silicone tetrachloride, so my formula is silicone Si. Chlorine, tetra means 4. Silicone tetrachloride. So silicone is in group 4, so silicone has 4 valence electrons. Each chlorine has 7. There are 4 of them, so here are 28. 28 plus 4 is a total of 32 valence electrons. My essential atom in this case would be silicone because that's the one found in least amounts. And yes, it's also the first element. I'm going to put silicone in the middle. Okay. Next step, I'm going to bond all of the other atoms to the central atom using single bonds. So I've done that. Okay. My next step is fulfill the octet rule for all other atoms. But so far I've used up 8 valence electrons. So I end up with 24, I'm sorry. I have 4 to use between these chlorines, so each chlorine can get up to 6. 2, 4, 6, 2, 4. I'm going to erase this little line over here for now. 6, 2, 4, 6, 2, 4, and 6. So I used up all 24. Okay. So next, I go to my central atom. My central atom is perfectly happy. So now all atoms are fulfilling the octet rule. Next, I have silicon dioxide. So I have silicone Si. Di means 2 oxygens. Again, silicone has 4 valence electrons. Each oxygen has 6, but there's 2 oxygens, so there's 12. 12 plus 4 is 16 valence electrons. I identify my central atom, which would be silicone. I use single bonds to bond my oxygens. So here I've used 4 electrons already. I'm going to distribute those 12 between my outermost atoms, which would be oxygen. So each oxygen receives 6 valence electrons. Okay, so I used all 12. Now, I have to check, does each oxygen fulfill the octet rule? It sure does. 1, 2, 3, 2, 4, 6, 8, 2, 4, 6, 8 oxygens are happy. So now I have to look at silicone. Silicone only has 4 though, so silicone is not happy. So again, each oxygen has to share and create a double bond. So I'm going to erase these up here because they no longer belong just to oxygen. They also have to belong to silicone. Oxygen is still happy, 2, 4, 6, 8. Okay, silicone's closer to the octet rule, but now it needs the other oxygen to also share 2 valence electrons. And everybody's happy.